Hello, everyone. Today I want to talk to you all about a topic that doesn't get talked about as much in IoT. When we talk about IoT solutions, we really like talking about these millions of devices that are simultaneously connected to a single endpoint, pumping up, trillions of messages, and we're consuming them using our complex machine learning algorithms, gaining insights, and provoking a digital transformation of our businesses. But when we tell that story, we often skip the important step 0, which is connecting those devices to the cloud in the first place. And so today I'm going to talk about how we're making that extremely easy using Azure IoT. But before I dive into that, I first want to give you some context about where this really fits in to the device lifecycle. So you can think of the device lifecycle as a series of 5 parts. The first part is where you plan your IoT solution. This is where you figure out what exactly it is you are trying to do. Especially in terms of industry, this is what are you trying to accomplish when you're measuring something with your devices. If you're ThyssenKrupp elevators, your goal is to reduce the downtime of your elevator. If you're Steelcase, the goal is to have better space utilization and higher worker satisfaction with their workplace. So this, when I come from the service side of things, this is typically left as an exercise to the reader, so to speak, when I talk to customers. So they figure out what they want. And then once they know what their device scenario is, which particular devices they're using, then it's time to actually register these devices to the cloud. And when I say register here, I just mean just establish that initial connection, have the cloud know that these devices exist, and have the device know that it's supposed to go talk to some cloud endpoint to send its telemetry up. So once the device has that initial connection established, then we configure that device with the initial configuration it needs to exist as a device in the context of that solution. So if you have, for example, Steelcase deals with many different customers with their smart buildings workspaces. Each different customer is going to have a different set of requirements around how they want their spaces to be set up, which means each of those devices, even though they might be the same hardware model number, require a different configuration in order to work properly. So once devices have been registered and configured initially, now it's time to monitor them. And this is where the device will spend most of its rest of its useful life, is in the monitor phase where you're just reading the data, analyzing the data, producing insights, sending commands back to the device, et cetera, et cetera. And what we find is there's often a tight looping between the monitor and configure step, especially as new software becomes available or new insights about the devices becomes available. Where we monitor the device, we realize something new is going on, we push down a new configuration to these devices, then we monitor all these devices to make sure that configuration was applied properly and continue monitoring that device. And ultimately, at some point, the device will reach the end of its useful life. So at some point, 5, 10, 15, 20 years down the line, either due to physical failure or just the general lifespan of that device or being replaced by a new model, that device will be shut down and be replaced with something new. What I'm going to focus on is how we are combining these register and initial configure step into one automated chunk to make everyone's life a whole lot easier using Azure IoT. But first, I want to give you a quick orientation because provisioning and registration and configuration are all very overloaded terms in IoT. So here you've got the V1 of the remote monitoring pre-configured solution, just kind of as a stand-in for a generic IoT architecture. IoT Hub in Azure is where all the devices are sending their data to the cloud as the cloud ingestion point. And provisioning happens in establishing that bidirectional communication between the device and a cloud. So when we talk about provisioning devices to Azure, what I really mean is provisioning devices to IoT Hub in particular. And because I've been doing this IoT thing for a while, I want to define what I mean when I say provisioning, so we're all on the same page here. So to me, provisioning is that 1-2 punch of registration and configuration in the same step. If you're not doing both of those at the same time, or if you don't have both of those completed, then you can't really say that a device has been fully provisioned, because really it's been half done if it's only registered, but it still has no initial configuration applied. Same if the device has a configuration but no cloud connection, it hasn't really been provisioned to that IoT solution at all. Now, provisioning is hard today for a variety of reasons, and first and foremost is a general security best practice that's true regardless of the platform you're using, and that's that solutions and devices must have unique per-device revocable access. This is so that if you have one device that, for whatever reason, either goes rogue or gets hacked, you can shut down access to just that one device without crippling the rest of your solution and further polluting your downstream data processing efforts. Provisioning today is a very manual process, and manual processes don't really work well at IoT scale. And a lot of this problem comes from that first problem that devices have to have per device unique revocable access. And this means that every device has to have a unique ID and key in that device injected into that device at some point in its manufacturing process. So this could be done in the factory, where you just mass provision as part of the pipeline, but that assumes that you have a lot of foreknowledge about where this device is going to end up, and surety that that device will in fact end up exactly where you say it is. Otherwise, you're going to have to find that device somewhere en route to its final destination, take it out of the box, plug it in, put in a new key, put it back in the box, put it back on the truck, and then send it on its way. The second way you can do this is when the device ends at its final place to be installed, you have a technician who takes the device out of the box, plugs it into the computer, puts in a unique ID and key, takes the device, installs it in whatever location is possible, and then goes on to the next device, which itself is wrought with some issues in case of maybe somebody typos, or maybe a box was mislabeled or placed on the wrong pallet. And then you have other issues down the road when you try to make sure that all of your data processing in the back end actually can account for this new update. So very difficult to do this at scale when we're talking about doing this millions of times rather than just 1 or 2 times when you're playing around with your own prototype boards. Similar to this ID and key, there's the initial configuration is another issue, where how do you get the right initial configuration on that device without having to do any sort of manual step along the way? Because the initial configuration could change when the device is en route, and sometimes devices sit in warehouses for 6 months, maybe even a year, before they actually move from that warehouse, depending on the supply chains that we're talking about. And as we'll see in a sec, supply chains are rather complicated. Now, they're more than just the device lifecycle we have to think about, but we have to think about the business lifecycle as well. Some customers I've talked to have actually built their own provisioning service, just unique for their own devices. And one thing that they have to deal with is, in case of, example, mergers and acquisitions, you now have a URL that's unique to that one or to that one company that's merging with another company, and both of those sets of devices have to point to somewhere. But how do you update these devices, especially given that some of them might be sitting in the aforementioned warehouses waiting to be shipped to their final destination? Not only that, but if on the off chance a company goes bankrupt, you have a similar thing where suddenly that cloud endpoint's now been shut down. So this device is essentially a brick. So you have to consider what's going on with the business and how can you best protect these devices from different sorts of lifecycle events and make that type of transition a non-issue for your devices. And as I mentioned, supply chains are complex, often much more complex than we like to think they are, especially if you, like me, are coming from the cloud point of view, where devices are basically small databases just emitting data. There's actually a lot more to that, as I've learned. And first and foremost is that building devices is complicated. I really, really, really want to tell you a nice, simple story about how everything works out well and how it's very easy to do actual device registration without having to deal with the pure fact that devices are complex machines and go through a complex supply chain process when you go to manufacture them. It's naive to think that it's the same company that's manufacturing the device and building it and writing the software that goes on it and building the cloud solution that it attaches to it and deploying these devices and then monitoring that end result. And we have to keep that in account when we think about how we're going to deal with device provisioning over the life cycle of the device. The most common supply chain pattern that we found goes OEM to ODM to systems integrator and finally to the end customer. And this is one of the simple ones. Oftentimes you can have a whole lot of other little steps where I have arrows on that slide, depending on what the device is and how complex and how many different ODMs are involved and where your certificates are coming from. And updating this process, this manufacturing process, is basically impossible for all intents and purposes. It involves not only dealing with very large pieces of manufacturing machinery that stamp out, different type pieces of metal or injection mold very specific pieces of plastic, but also the human capital involved as well. Retraining these trainers to now use the new big machines that you're using to build the new plastic devices or metal or what have you. And then retraining that, and as soon as you tell a customer that, oh yes, you're gonna have to change their supply chain, it's immediately a non-issue. They're like, well, we can't do that, it's too expensive, the end. So we need to fit into this existing supply chain, and we have to deal with the existing supply chain problems, such as producing certificates, injecting certificates into these devices, reflashing devices at every stage along the supply chain, and then dealing with data ownership changes as this device changes hands, and then synchronizing the backend databases at the end of the day. Now, the fun fact about that last bullet point is that there are unique companies for whom each and every one of those items has, they pick one of those items, and that is their business plan. So that is what they do, is inject certificates, for one example. So I want to give you an example of connected cars. So cars have, obviously, a lot of different pieces, and these pieces come from different ODMs, from tires to engines to, I don't know, maybe the muffler. I know tires, I once interned at a tire company. So you have these different pieces that the car company specs out, and it says, okay, great, we know we want this, tread depth of tire, what have you. And then the OEM will then buy however many of this one type of tire and use it in, one line of vehicles or perhaps multiple different lines of vehicles, depending on what they want to do and what the economies of scale look like there. So now they hire a systems integrator who will then write software for this particular device to have it send data up to the cloud when that device turns on. These devices then get shipped all over the world and connect to the IoT solution in their geo, or it could also be based specifically on that make and model of the vehicle. So maybe there's a different, you've got the crossover vehicle and you've got the small compact, and they both have different sets of cloud solutions because they're different vehicles used in different ways. And then finally, that car manufacturer can collect this data, share that data with the ODMs, and everybody is happy at the end of the day, assuming everything went well in this very complex process. And this is one of the reasons why cars have a very long lead cycle when you're actually producing vehicles. So taking all this into account, we set out to solve this complex problem, which are my favorite. And we created the Azure IoT Hub device provisioning service, which went into public preview as of 3 weeks ago. And it offers dynamic, just-in-time provisioning of a device to a specific IoT hub within a multi-hub solution at the time that that device turns on for the first time. We support IoT hubs across the entire world when that device first turns on. So with one provisioning service, you can deal with a geo-sharding type scenario where you'll have one device connects in the US and one device connects in India. And there's an animation showing what that looks like. We also offer URL stability, which our customers tell us is one of the most important things, so that when their device goes along that supply chain, they don't have to take it out of the box and reflash it just to update a URL. It's ridiculous to have to do that, and would much rather figure that out on the back end, make that the cloud's job, rather than have to deal with a physical device having some string burned into it that can change really easily. Speaking of strings burned into devices, we have enhanced security via hardware security modules. And we've made it as easy as possible to use hardware-based security modules because those are the most secure way of storing the keys on your device and one of the best ways of securing the device by securing the secrets themselves. So if you have your keys stored in an HSM, those keys and that HSM exist in a protected area. And so you can have the exact same version of the firmware on every single one of those devices, and the only thing that's changed is something that's inherently physical to that device, which works very well at scale because you have to produce those things one at a time anyway. Because it's automated, we also remove a lot of the human error, and we make it easy that if there is human error, you can just update it through the portal because it's a web backend, and you don't have to take any physical device and have physical access to that device in order to provide an upgrade. We have, and then we also want to make this compatible with every single device that can connect to IoT Hub today. I'll get into that in a bit later. So we have some overall goals for device provisioning with Azure IoT that I wanted to share just so you can get a sense of where we're coming from. And first and foremost, as you'll hear me say a lot the rest of this presentation, is that security is foremost. If we're going to automate a process, we want to make sure that it's secure from start to finish. And really what automating provisioning is about establishing that secure root of trust between that device and the cloud at that moment that device first establishes connection. You don't have to deal with adding security later. You don't have to deal with maybe having to make sure that key is securely entered, because when that device turns on, we validate its identity at the very beginning, and if it does not check out, we don't let it connect. We also know that our customers do more than just apply one type of device to one single IoT solution. And there are many different scenarios that our customers deal with provisioning. So multi-tenancy support, it was crucial for us to include in the V1 of the service. Similarly, there are many different ways you might want to assign devices to a solution, based, for example, on the make model of your vehicle, or the customer who purchased a batch order of devices, or whatever the customer wants to do, we want to provide support for that. So that was our third guiding principle with device provisioning. And I could easily spend the rest of the time talking about the various provisioning scenarios that we support, but I won't because there's lots of them. But I'll go over these 5 just really quickly so you can get a sense for the wide variety of scale that is available today in the public preview. So just imagine what we're going to do and get GA. So first off, of course, is that initial connection between the device and the cloud. This is the very simple, I've got a million toasters and I want to connect all of my toasters to my toaster app at the back end without having to do anything fancy. I just want to do toaster to cloud without having to individually inject a key into every toaster. We do that, of course, but we also offer load balancing in order to provide better management if you want to manage your devices across multiple IoT hubs instead of just one. A more refined version of this is that ownership-based, where if I have a set of devices that I know were purchased by, Relic Cloud Incorporated, that they need to have their own devices connected to their own IoT hub, that's possible today. Similarly, location-based. So going back to my toasters, let's assume I make the best smart toasters back in Redmond, Washington, and I ship my toasters all over the world. I don't want my toasters that end up in Perth, Australia, connecting to the West US data center when they could be connecting to the IoT hub in Australia, because that would create burnt toast and everybody's breakfast would be ruined. So we're going to allow geolocation-based connection to minimize that latency between the device and the cloud, and do that when that device first boots up, rather than where that device was physically manufactured, because that doesn't mean anything in terms of where it actually winds up in today's world. And last but not least is reprovisioning. Reprovisioning is one of those scenarios that you tend not to think about at first when you're first planning your IoT solution, because it involves things that happen after the fact. And this could be due to any number of things. It could be due to a change of ownership. For example, with a leased vehicle where my lease is up, I return it to the dealership, and they then lease it to somebody new. They want to wipe my data and put it in whatever that customer has selected. It could also be due to that device moving around. Maybe it's a container ship, and that container ship makes long voyages across the ocean. And when it pulls into port, it wants to be able to unload its containers, the shipping containers as quickly as possible, and upload all the data it's collected along its journey to the IoT hub closest to it. Similarly, and this is one of my favorite, going back to security, is reattesting that device's identity every once in a while. Depending on the context in which this device is used, it might be used in a very secure location that has very strict requirements on reproving that device's identity. It could be every 90 days that device has to check in and say, yes, I am still valid. Yes, I am still valid. It could be 30 days, or my favorite, one customer we've talked to needs to reattest daily based on the context in which their device is being used. So this is all great, and this is more from the service side of you. And now I want to talk about how a device relates to the device provisioning service. And for this, I want you to think of the device provisioning service as kind of the device's concierge to the cloud. So all of you, when you came here into Orlando, when you checked in at your hotel, you went up to the concierge and you said, hello, I have a reservation. And they say, okay, thank you, can I see your ID? And you give them your ID, and they're like, okay, here you go, your room key, your room 214, your elevator is around the corner to the left. It's pretty simple. You don't have to deal with picking your room ahead of time, making sure that there's a bed, dealing with all of that. You just go up and you say, help me, where do I go? And they say, you go over there. Devices use the device provisioning service in exactly the same way when they boot up. They turn on, they go to the global URL, and they say, hello, I'm a device. Here's some unique identification information about me. Where do I go? And the DPS goes, yes, okay, you're in my list. I approve of you. Based on what I know about you, I'm going to create a device identity in this IoT hub over here. And hey, device, here's your connection information. You go talk to that IoT hub. I'll get out of the way. Let me know if you need anything. Similarly, there are some devices that actually can't permanently store keys. They're very low resource devices that just don't have anywhere to, like any sort of memory that persists over reboot. And so what the DPS does in this case is it acts almost like an external store for that device. So the device turns on, it goes, hey, who was I again? And the provisioning service goes, oh yeah, here's your IoT hub, go connect over there. And the device goes, thank you, and it goes connects to the hub. And it gets better because as a courtesy, we roll the key for you if you're using SAS token-based connections in order to provide that extra layer of security. And all it does is just make it kind of almost like a one-time pad where every single time you reboot, you get a new key, and you're like, hooray, everything works well. And going back to the hotel analogy, it's like you lose your key, you go to the concierge, and you're like, yeah, I lost my key, and I don't know where. Can you please just rekey my room? And they go, yep, here you go. Thanks, please don't try to lose it again. And last but not least is the hard reset. And this is where the device wants to forget all about who it is and be assigned a new identity and become a new person, well, new device, and exist at in a different solution. This is like when you go to the hotel and you want a new room and they just kind of move you. They say, okay, now you are room 327 or what have you as a result of your move. So that's all well and good. Of course, this is a 400 level talk, so everybody now wants to know how it works. So before I get to show my demo, I want to talk a little bit about the setup, because like any automated process, there's a little work to do ahead of time, because automation only works if you actually link all the pieces together. So first and foremost, that the device has to know that global URL to go to talk to in order to find out where it goes at the end of the day. It also has to know how to deal with the information it gets as a result. All of that is very easily done if you use our device SDKs. Secondly, the enrollment list has been populated, and this is basically where you tell the device provisioning service, here are the list of devices or the list of groups of devices that are allowed to connect at some point in the future. The provisioning service also has to know the IoT hubs that it's allowed to assign devices to. And again, security, you have to explicitly set up those links. And finally, you have to tell the service how you want to allocate devices among the linked hubs. So first, I want to dive into a little more onto the enrollment list. And the enrollment list is essentially the record of all the information needed to fully provision that device. From attestation information, like how do we validate that device's identity, to the initial configuration that we want that device to have when it boots, to any other additional device information, like explicitly setting an IoT hub, or specifically specifying a device ID we want that device to be known as when it's in that IoT solution. I mentioned that we support 2 different types of enrollments. We offer individual enrollments, which are great for solutions where every single device has to have a unique setup. So this is really good for devices that need to be individually configured and have very specific things that need to be set up ahead of time. And this is also good for 2 different types of attestation, both TPM-based or SAS token-based, as well as X509 certificates. Enrollment groups, on the other hand, are great when you have a large number of devices that all need the exact same configuration. And you can, in this case, we're leveraging that security aspect of using our root CA as kind of the source of identifying a group. So what you do is you say all devices that have been signed by this root CA or this intermediate CA, whatever signing cert you're using, are part of this enrollment group, and they will all have the exact same characteristics, from initial configuration to where they're supposed to go to whatever you want to set in that group. And the best part about this is that this is updatable throughout the supply chain. So all you have to do is call an API and say, or go into the portal and say, okay, I wanted to change this value to be this value because this one device got moved over here, now it needs to update. It's pretty easy. Linking an IoT hub is just how we say when you're telling the DPS it now has permission to register devices to this hub. And the best thing about this is that linked hubs can be cross-region from the device provisioning service, and they can also be cross-subscription. Going back to that multi-tenancy aspect, allowing this cross-region, cross-subscription gives a lot of flexibility to customers to configure how they want their devices to register and what type of solutions they're doing without having to deal with building their own intermediate glue and dealing with all of that and having that stand up all on its own. Allocation policies determine how the DPS provisions devices to the various linked hubs. And there are 3 main ways that you can choose to allocate these devices. The first one is just you evenly weight it. A device comes in, it's got an even chance of going to whichever hub is linked, and we try to keep those levels about as same as possible. Then there's, again, the lowest latency, or the geo-sharding, where the device is assigned to the IoT Hub that has the lowest ping length between it and that solution, so that you reduce that latency, have better connections between that device and the cloud. And then you can statically configure this in the enrollment list. And this is where if you have a customer who buys 100 devices and you don't want to deal with this geo whatever and the evenly weighted what have you, and you just say, I want all of these devices for sure to go to this one IoT Hub, don't do anything at runtime, just put these devices over here. We can do that too, it's fine. You just set that in the enrollment list as well. And whatever your allocation policy setting at the hub or at the service itself, that can be overridden in the provisioning service. So for example, with going back to my toasters, I have my toaster DPS set up to be geo-sharding. So I've got lowest latency settings. And then I have Microsoft come to me and say, hey, Nicole, I want to buy 100 toasters to pilot in the building you work in, but we want to make sure that they are put in this one IoT Hub so only we can monitor them. I can say, all right, great, thanks Microsoft, sounds great, I'll get working on your toasters. And I just say, all of those 100 toasters are going to Microsoft IoT Hub. And what happens is I don't have to update the allocation policy setting on my service at all because I put all that information in my enrollment list. And as I'll show you in a bit, that's one setting for all 100 of those devices, which is pretty great. So that being said, let's see that in action, AKA it's demo time. So let me log in to my machine. And so what I'm going to show you is using this little demo board that those of you who are at the pre-day on Sunday have seen before. It's a dev kit device. It's based on Arduino. It's a fantastic little board. It's got a whole bunch of different sensors. And my favorite part is a little security chip that if you look at the keyboard and you've got the capital P, the security chip is about the same size as the inner part of that capital P. So it's teeny, teeny, tiny little thing. And I'm going to be using that security chip to securely store the keys in my cutesy little demo board. So now let's play, let's pretend, because the stories are more fun. So now I'm in RZILD appliances, and I use this little board as a control board for the appliances that my company builds. I make refrigerators and washing machines and dishwashers, and I'll use a board like this in order to power them and monitor them and make sure that they're working up to snuff. So for this, I have a manufacturer that's making a bunch of these boards. I don't really know which line they're going to be used for, nor do I care, because they're all basically the same. And so what I can do is in the provisioning service I have, I'll show you what I have set up. So I have in my enrollments, I have an individual enrollment for this particular device right here, where you can see what I've set up ahead of time. And you can see it's not registered at all. I've got set up with an assigned IoT Hub device ID, but I let it specify the hub at runtime. I've only got one hub assigned. And I've got an initial twin state specified as well. So what happens is when this device turns on, it'll register with the provisioning service. The provisioning service will create a device ID in the IoT Hub that has that desired that tag set on it. So in order to do that, all I'm going to do is connect my little external battery to my demo board and have it turn on. And then wait as it connects through the horrible conference Wi-Fi, which you can't see because there's no camera, but it says connecting on here as it's connecting through the Wi-Fi. And then in a couple of seconds, it will say connected to DPS. So and then I can refresh this list, and you can see it showing up here as well. Now it's saying it's running, so it's going through the provisioning process, and it will be connected very soon. It's connected now. So if I go back here, you can see that the registration is assigned. And if I go to the IoT Hub that's linked here, this is just pinned to my Device Explorer, you can see that there's a device already there. All I did was power this thing on. That's all I did. And now if we go into this one device, we can see that it does, in fact, have my tag of Hello World enabled. Device twin, there you go, Hello World. Now, that's cute because I'm using tags, but imagine if this device had a horrible security flaw when they first flashed the firmware on it, and I leveraged the IoT Hub device management to update the firmware on this device at first boot. So what happens is I turn this device on, it connects to IoT Hub, it says, oh, I suddenly have a new version of firmware I need to apply, pulls that down, applies it, reboots, because that's what you have to do every time you apply firmware, and now it starts sending data, and you just patch a security vulnerability without having to take the device out of the box sometime along the line when you first found that vulnerability. So that's great. Now I've got 2 of these devices actually, because Van Arsdale Manufacturing is doing crazy good business. So I've got a second device. I'm going to go through that same process, just kind of plug it in, turn it on, and we'll go through that. And while I wait for the Wi-Fi to do its thing, I'm going to show up what I'm using for code for this device. So this is VS Code. This is a sample that you're getting a sneak peek of using this dev kit. And this is going live sometime in October once we actually just fix all the images and whatnot. And both of these devices are using the same firmware because we're using the hardware chip on them. And that's just fantastic that both of these devices can have the same version of the firmware burned in, and I didn't have to do anything different when I was flashing them. Now, if you're used to just like playing around with these on the weekend, this might be like, yeah, good job, like, okay. But if you've ever had to deal with a supply chain, you're like, wait, you mean I don't have to add a new step, or I can remove a step from my existing process? This is fantastic. So I've been connected for a little while I was gushing about automated provisioning. So we can go back to my IoT Hub and go to the Device Explorer, and you can see that my second device has been enabled as well. And if I go back to my device provisioning service and go to manage my enrollments, to my individual enrollments, you can see that when this loads, that this one has also been registered, and the registration status is there. So that's really great. But this really shines at scale. And as much fun as watching various unboxing videos can be, I guarantee you, watching me unbox hundreds of devices on stage would not be fun for anybody, including me, mostly me. So I'm going to simulate this because that's what you do when you can't unbox many of devices. And so in this case, we're going to be simulating elevators. And our company's name is First Up Elevators, and they've got the best elevators west of New York, or east of New York. So in this case, what I'm doing with my provisioning service, that's the hub, is I'm using that group enrollment in order to provision multiple devices. So when I go into this elevator group, you can see there's no list of devices that have been registered. When I actually go through this device ID list will be populated. But every single one of these simulated devices possesses a certificate that's been signed by an intermediate CA that I've specified to be part of this group. So every single elevator that First Up Elevators produces goes through this process. So let me go start up the script that will provision my devices. And you can see that's not what I wanted. OK, demo, this is why I have the binaries, provisioning. There we go. There we go. So I've just provisioned 100 devices. And if I go back to my enrollment group and load it, you can see tons of devices, and it paginates at the bottom. And like they're all there. And better yet, I've created a Power BI dashboard that shows data that's coming off of all of these devices as they've been connected to IoT Hub. So I just simulated 100 devices, automatically provisioning to DPS without having any connection information ahead of time, and then automatically going, OK, thanks for this connection information. I'm going to go talk to my IoT Hub now. Hey, IoT Hub, I want to tell you all about the number of passengers I've had on my elevator today. And First Up Elevators can now use this information to monitor the patterns of their elevators. And all they have to do when they're installing these devices into their elevators is plug them in and turn them on. So that is the magic demo portion of that. So now I'm going to actually talk you through what actually happens in the background that makes this magic work. Because the next question that everybody likes to have is, OK, Nicole, what happens on the wire? But first let's talk high level, and then we'll go to the wire. It's coming. So at a very high level, what happens is the device turns on. It goes, hey, device provisioning service. Who am I? Where do I go? DPS goes to IoT Hub, creates that device identity. IoT Hub returns that ID. DPS gives that ID back to the device. And now the device can connect to IoT Hub and receive information from IoT Hub. Now, that's the very high level, 100, 200 level. The 300 or 400 level, here's what happens in the more engineering slides of when a device provisions and what data exactly is being passed along the way. Each DPS can be linked to up to 10 IoT hubs, which is why more than one is listed, but those are going to go away in a little bit to keep the slide from getting too busy. So the first step is to populate the enrollment list with the device enrollment information. This is telling DPS that I've just produced a lot of new toasters. They've all been ordered by Microsoft, and here's an enrollment group that I'm using to track that request. Now, one of those toasters turns on, and it goes, hey, where do I go? Provisioning service will validate that device's identity against the enrollment list, and then once that passes, it will then create that device identity within the IoT Hub. It will then pass that registered device ID back, give it to the device. Now the device can establish a connection and pull down that initial configuration information and then apply it automatically. The device now starts sending device telemetry, which then gets consumed by your back-end business logic to produce business insights, and that gets ultimately sent back to the device at the end of the day, et cetera. So that's fantastic when you're using one of these things. But I did mention global URL, and so some of you might have been wondering, how does that work when you have multiple tenants all talking to the same URL? How do we keep that straight? And the answer is that we keep track of that within the service itself, and we use something called a scope ID to scope the device down to the device provisioning service that it ought to talk to at the end. So for device A, it comes to talk to the provisioning service. Provisioning service says, okay, thanks, I know who you are, you go to Hub 1, we're going to create you, and now this device can talk to IoT Hub, Hub 1. Device B comes along and says, hey, same URL, I'm device B, where do I go? And they go, oh, you're device B, you go to DPS 2, and IoT, or IoT Hub 2, and now the device can talk to IoT Hub 2. That's, again, the high-level version. The more, here's what's actually going on in more detailed version is device 1 turns on and it sends 3 pieces of information to the device provisioning service. The scope ID, the registration ID, and some sort of secret, either X509 certificate or some SAS token-based token. The global endpoint will say, all right, we're going to look in our mapping database, and based on this ID scope and registration combination, we uniquely identify you as going to Contoso DPS. So we route that request to Contoso DPS, and the provisioning process continues as usual. Now device 2 comes along, and it goes, hey, I have a different ID scope and a different registration ID, and the mapping database says, okay, you go to Relic Cloud DPS. And this is how the backend keeps it all straight. So I want to talk a little bit more about the SDK support that we have in the public preview. We have a C SDK available for the devices, and it composes very easily with the existing device SDK for IoT Hub. And we only offer HTTPS protocol support, but with full languages and protocol support to come when we go generally available. Service SDK has a similar story where it's accepted C# and HTTPS for managing the service now, with full language and protocol support to come, or full language support to come in GA. And the ultimate goal is to offer the same device support that IoT Hub offers. We're provisioning devices to IoT Hub, therefore the same types of devices that can connect to IoT Hub ought to be able to provision to IoT Hub via the device provisioning service. Now the part all the security buffs have been waiting for, where I get into the details of what's actually going on the wire when we talk about this flow. So first, I want to give some details on verifying a device's identity. And the first is that, as I mentioned, there are 2 types of device attestation that's supported. X509-based, just following the standard X509 auth flow, and then using the Trusted Platform Module specification for verifying possession of a TPM's private endorsement key. Note that I said specification. You do not have to use an actual physical TPM in order to work. And in fact, there are 4 ways of supporting keys that we support in DPS today. HSMs using X509, and these are in order, by the way, from most secure to like lesser layers of security. I don't want to say least secure because it's still secure, and it's more secure than just hard coding in a string, but I guess from secure to most secure bottom up. So most secure absolutely is using a hardware security module using X509 certificates, which is what my little dinky little devices, which are actually quite high powered, use to store their key. They're using a ST safe chip in order to securely store the X509 certs that got flashed into them. Next up is the actual physical trusted platform module. If you're using a Windows laptop for business, you probably have a TPM on board, and that's what you use for securely identifying that device. And for a TPM, the security aspect lies in a private endorsement key that is uniquely identified by that one device that you cannot absolutely get at, and we use the public portion of that endorsement key to verify it. Then, kind of going down the list, we have emulated X509 certificates. If you don't have an HSM to store your certs, you can store them in RAM if you really want. And then you can also use an emulated TPM, which just means that you have to talk the TPM protocol between the device and the cloud. The cloud itself doesn't have any way of being like, oh, that's not a physical TPM. We don't trust non-physical TPMs. You just have to go through the handshake. And there are basically 2 steps as well to the provisioning process, depending on the personas involved. And this kind of gets back to the whole supply chains are messy. Sorry, but I can't change that fact. There are 2 main personas involved and 2 steps for that. And then the first one is the manufacturer step, in which the enrollment information is harvested and placed in the enrollment list. And this service is offered by a lot of hardware manufacturers and HSM vendors today. And the second step is the registration step, in which the device phones home to DPS. So these can occur out of sync from one another. You just have to have completed the manufacturer step before you go to the registration step, which, when you think about the timelines, kind of makes sense. Now let's go to the fun parts. I'm going to show the flows for both those steps, for both TPM and X509. And sorry for the small font, but as you'll see on the next slide, I didn't have much choice. So this is what the factory provisioning step looks like when you've got a TPM. And what this is doing is harvesting the TPM. So you get the public portion of the endorsement key, you have that information, you put that in some central store that then gets uploaded to the enrollment list at the end of the day. This slide is really busy because this is what's going on the wire, but suffice it to say, what this is showing is a nonce challenge. So we do a nonce challenge using the endorsement key information, and actually so what happens is the device, when it turns on, sends not only the EK public, but also the storage root key to the service. The service will create what's actually a SAS token used to connect, encrypts it with those 2 keys, sends it back to the device. The device, because it has the private portions of the endorsement key and the storage root key, will then decrypt that nonce and get the SAS URI back, which it can then use to reestablish the communication with the device provisioning service, which will now allow it to proceed through the provisioning process. I know it's complicated. I believe the slides will be available after the conference, so you can peruse these at your leisure. Next up is the manufacturing flow for X509, which is a little easier because it's a lot better or more commonly used, where X509 is used all over the place. And in this case, we're just talking about how do we create a certificate, how do we produce a certificate and inject it into the device and somehow retain some sort of information about that cert. If you're using an individual enrollment, all you have to use is the thumbprint of that X509 certificate from that leaf certificate to prove that device. Or if you're using an enrollment group, you have to go through an proof of ownership flow with the service first to say that I will have a group that was using this particular signing certificate. Let me prove to you that I actually own the signing certificate that I say I own. And then you can then use that signing cert to produce leaf certificates that are then placed on all the devices. And then the registration flow for X509, it just follows standard X509 protocol over TLS on the wire. So we are actually doing quite a lot of work to try to make this whole security thing a lot easier to understand, so you don't have to go down to what's going on the wire in order to make sure that my device is secure. Because at the end of the day, that's what we all want, right? We all want our IoT stuff to connect to the cloud and not get hacked. And so there's effort that's coming out of Microsoft research through the Trusted Computing Group called the Device Identity Composition Engine, or DICE for short. So what we're doing is helping standardize an IoT architecture that is secure by design and runs on the lowest level of hardware requirements possible. Ideally, that runs on hardware today to just increase the security of the hardware that's involved. And actually, this SD-Safe chip is running DICE. And this uses silicon gates that create that hardware-based device identity. So if you want to blow the device identity, you change the silicon gates, and you're done. It's built into the DNA of the devices. Again, like you change the silicon of the device, you change the device itself. And it's a scalable security framework with minimum hardware requirements for device identification and attestation. Back in April, we announced a couple of hardware partnerships with STMicro and Micron about involving DICE, and we're working with them to try to get more secure HSMs that are easier to use for everyone and offer this very high degree of security in the best way to secure the IoT devices. And again, we use that hardware-based security as an anchor of trust between that device and the cloud for the entire lifetime of the device. So there are other ways of dealing with the DICE that get a little more complicated that I don't have time for, that involve using that physical chip and computing basically based on the firmware, computing that X509 certificate that you then present. And if something happens to the firmware, you know your device has been tampered with. And it's very interesting, and we should do another session on that later. And if you want to learn more, go to aka.ms/dice. So to wrap it up, because I'm over time, the device provisioning service is available everywhere. It'll make your provisioning go as easily as my demo did, where you just kind of plug it in, turn it on, and everything connects up magically. So your homework for this session is to read more about the IoT Hub device provisioning service on our documentation and try out the tutorials. You don't necessarily have to have a device to try it out, but it'll work if you have one. And check out some of the other Azure IoT sessions. Particularly, there's one tomorrow towards a trustworthy Internet of Things that will go into the security involved around DICE in a little more detail. OK. These slides will be available online later, just so you know. But feel free to take pictures. OK, I'm going to go now. Great. So there are other IoT sessions. They're also in the catalog, et cetera. Please evaluate the session. And if you want to ask me any questions, I'll be around a little later. Or you can ping me on Twitter @nbirdie or #Azure IoT DPS. Thank you all for attending.